Next up, we have Stanimira Vlaeva.
So, welcome to my session today. My topic is how we can use the Angular CLI and more specifically the ng-add command to make our library setup frictionless and easier for our users. And our users are other developers, and we don't want other developers to hate us. We want them to love us, right? So my name is Stanimira Vlaeva. I'm from Bulgaria, and I'm part of the NativeScript team. I'm also a Google developer expert for Angular and web technologies. And I mentioned NativeScript. How many of you have heard or used NativeScript before? Oh, that's great. That's very cool. It's a great validation for me. So for those of you who didn't raise your hands, NativeScript is a framework for building native mobile apps for Android and iOS using basically web technologies. So you can use plain JavaScript or Vue.js, or you can also use Angular. And NativeScript is very well integrated with Angular. You can actually have a single project, and from that project you can build apps for web and for Android and iOS. And you can reuse a very huge part of your business logic. So why am I saying all that? Well, let's try to add NativeScript to your existing Angular project and see what's the problem. So the first thing you need to do is you need to install NativeScript Angular. Then you need to install NativeScript Webpack. Then you need to install a bunch of other plugins. Then you need to update your Angular JSON file to add NativeScript to it. Then you need to add a TypeScript configuration for NativeScript. Then you need to add a new entry module for NativeScript. Then a new root engine module. Then new bootstrap component, and so on, and the list is very long. And I don't know if you agree, but for me this process is quite tedious. It's quite slow, and I really don't want to do that every time I need to add NativeScript to my web project. And I was wondering, can't we just automate that, make it easier for our users? And as I said, our users are actually developers, and developers love automation. So here's where the Angular CLI can help. If you're an Angular developer, you obviously have used the Angular CLI. It's very cool. It provides you with nice commands like ng-new for creating new projects, ng-serve for building your projects and updating them while you develop them, or ng-generate to bootstrap components, modules, and stuff like that. Like, the Angular CLI is awesome. And there is also this command, ng-add. Just a quick survey. How many of you have heard of ng-add before? Great. You're really smart. I can just leave. You know what is ng-add. So ng-add, very quickly, as an example, if we add NativeScript Schematics, this will install the NativeScript Schematics plugin from the npm registry, and then it will execute some kind of project transformation. And that project transformation is actually shipped inside the NativeScript Schematics package. And whenever I say project transformations, in this presentation I mean schematics. So very quickly, what is schematics? It's a project transformations tool for scaffolding, updating files, and executing tasks such as npm install and git init. And if you're like me, my first reaction when I read that was a bit like that. So let's just see a quick example and make this all clear. Again, if I add NativeScript Schematics, here is the output I will get. So first, I have installing packages for tooling via npm. This is the task that is executed. We're executing npm install. Then I have create, and I have 3 listed files. So these are the files that will be generated inside my project. And then I have 2 files that are updated. So basically, their content is modified somehow. So these are the project transformations, really. But why don't I just use, I don't know, some random bash script that modifies the file system and never bother with schematics? Why do we need it, and why it was invented? Well, the first cool thing about schematics is the atomic updates that it provides. Let's see what will happen if we use a bash script to modify the project. As an example, you can think of a library that you install from npm, and on the post-install step, the library modifies the project somehow. It uses the fs module, for example, from Node, and it does some modifications. So first, we modify the package JSON. For example, we add a new dependency or a new script inside it. And what happens is the package JSON is modified on the file system, obviously. Then we try to create a file. But the file src app module already exists, and we get an error. And at this point, the package JSON is modified. So we're in that kind of weird state where the whole transformation didn't actually happen. Half of it happened, and our project may be broken at this point because we didn't get the whole transformation. We got half of it. And maybe if we're really smart, we can try to roll back the change and handle all of that. But if we use schematics instead, we don't have to think about rollback. So the same set of actions, modify package JSON and create src app module TS, is actually executed as a transaction. So schematics will try to apply the changes on a virtual file system. It will take a copy of the existing file system. It will create a virtual file system. We'll try to execute the two actions. And we'll see that these actions cause an error. So it won't actually apply the transformation on the file system. And we'll get the project. It will be just the same as when we started executing the schematic. The other cool thing about schematic is that they're composable. So if we install a schematic library from somewhere, we can use the schematics defined there within our own schematics. So we can basically compose them. They're also pretty easy for unit testing. And we will see an example of that probably later. And the other biggest thing that personally I love the most is that they're declarative, and you write them with TypeScript. They're great typings for schematics, and it's very easy to get started. And it's very hard to do stupid errors because you have type safety. A little bit about collections. So what is a schematic collection? It is a set of schematics that you can add to your project, and the Angular CLI will use them. Maybe I forgot to mention that the ngGenerate command actually uses the schematics Angular collection. This is the default schematics collection that the Angular CLI uses. So this collection contains the schematics for generating components, ng modules, services, and all the things that we know from ngGenerate. But there are other collections as well. For example, there is the NGRX schematics, which can help us generate and bootstrap NGRX things in our projects. And of course, there is the NativeScript schematics, which we recommend for people to use in NativeScript projects because they're a little bit specific for mobile apps. All right, let's see some code already. How to get started with schematics. The easiest way is to install the Schematics CLI from npm. Then you can use the Schematics CLI to generate a new collection. It's basically a new library which will contain your set of schematics. And this is how a simple collection looks like when generated. We have some just build scripts, like the package JSON, which defines our dependencies, the TypeScript configuration, because it's written with TypeScript once again. And the most important thing is the collection code. We'll take a look at the collection JSON file first. The collection JSON file is like a registry for our schematic rules. So we have a schematics keyword, a schematics object, and inside it we have our commands enlisted. So the my collection schematic has some factory, right? What is a factory? Let's take a quick look at the file where the factory pointed. So factory, whatever, my collection, it's a function which returns another function which returns something. Okay, I think let's take a quick pause and just talk a little bit about theory. Okay. First of all, a tree in schematics is probably the most important concept. And the tree is just composed of two different things. A base, for example, the directory we are in. This is the representation of the file system, but in memory. It's our project and all the files there. And some actions that will be executed on the file system. That is the tree. A rule is a function. The rule function takes a tree, then it applies some things to it, and it has to return another tree. And whenever the rule is executed, these actions will be applied to the base or to our current directory or wherever we point schematics. So let's see that code again. So we have a factory function. The factory function is factory for rules. And essentially the rule is this thing that I showed you on the previous slide. It is a function that accepts a tree, and in this case, it doesn't do any modifications, it doesn't create any actions, it just returns the same tree. All right, now we know what is in our project. We can start developing and hacking it. So we just run npm install first, that's very important. And then something that I like to run is the TypeScript compiler in watch mode, so I can change files and they will be transpiled automatically. And how we execute schematics? This is the easiest way, using the schematic CLI. We can also use the Angular CLI, but this is like very easy for during development. So schematics, then we specify the directory with the collection. And if we do that in the collection root, this will be just dot. Then after the colon, we specify the name of the schematic. And in our case, when we created a new schematic collection, if we execute that, we will get nothing. Because we saw that our rule just doesn't do any modifications. It just returns the same tree. So this is everything we will see. OK, how can we log things in schematics? It's pretty simple. You see that OK? Because I can't zoom it, because it's an image, so I hope you see it. Because I don't really see it here. But it's fine, I'll improvise, OK. So we have to import the schematic context. We have to provide that as a second argument to the rule. Rule is the function. And then we can use context logger. And the context logger has different methods like info, error, debug. And if we execute that, we basically get some logging in our console. The context logger debug is very cool because you won't see any of these logs in production. So I recommend using that. We can also provide options to our schematics. So the options are passed to the rule factory, not to the rule itself, but the rule factory. And we can use them inside the rule. So through the Angular CLI and, of course, the schematic CLI, we can just pass different options like parameters. And we can then use them. Pretty simple, right? OK, the cool thing about schematics, we're getting to the meat of it. How we can create files. Very simple again. Tree create. We provide as the first argument the path to the file. And the second argument should be the content of the file. And that is it. That's all it takes to create a new file. Renaming and moving, very simple as well. Tree rename the old name and the new name. And we can also move files if we specify a whole path. The file will be just moved there. And by now, I think you're already bored with seeing just random statics, right? So let's try to code something. Do you know how much time I have? No? Anyone? OK, I'll just keep going. It's fine. So the first thing I wanted to show you, this is a different collection. This is actually the collection that we generated. And I think I have enough time, so I'm just going to code that. So let's remove everything. We have the rule factory, and we return a rule. So we need to return a tree in the end. What I want to do is take an existing file and modify it. And because I will execute that in the project root, I will just modify the package.json. So first I need to get the package.json from the file system. I can do that by using tree read and specifying the path. And this thing will actually return a buffer. So this is a buffer. And because that's a buffer, I have to convert it to string by using buffer to string. And it's probably a good idea to check if that buffer actually exists, if there is anything in it. So if we don't have anything in the buffer, I just want to return the tree. Cool. And the package.json file is JSON, right? So I want to parse the JSON to an object. Let's call that just OBJ because I'm not good with naming things. And we can use JSON parse content. But does anyone see a problem here with the JSON parse kind of thing? No? No? OK, so the problem is that this can be kind of invalid, and this will throw an error. So I want to catch that error just in case, you know. And if there is something wrong, I can log it with context logger error, and I can log parsing package.json failed. And I can just return the tree. Because I don't want to raise an error, I just don't want to do anything in this case. But if you want to throw an error, there's a special object called Schematics Exception that you can use for throwing an error. All right, let's use the object that we created. And actually, in order to use it, I have to define it before the try statement. All right, I already have the package.json parsed in a JavaScript object. So I can just go ahead and, for example, modify the dependencies and add some awesome library to the dependencies. And the version will be just some random version, whatever. And again, the dependencies property may not exist. So it's kind of cool to check first and assign it to a empty. OK, if we don't have dependencies, assign the dependencies to a new object literal. So far, so good. So how do we overwrite the existing file now? Well, we can use tree.overwrite. Again, we need to provide the path to the file, package.json, and then we need to provide the content. But if I just provide object, this is an object, and object to string will return object, and that's not cool. So that's why I need to actually stringify the object. This will stringify the object and save it to the file. All right, let's see what we did. Again, I can execute schematics with the Schematics CLI. I'm in that project. And how was my schematic called? My collection. OK, I can actually check in the collection JSON. That's the easiest way to check the name for your schematic. So this is the factory function, index, my collection. And my collection is called my collection. This is a weird name for schematic because it's not a collection, but it's a schematic, but that doesn't matter. So schematics.my collection. And this says that the package.json is updated. Let's see what happened. Nothing. That's weird. And at this point, you really start to question your life decisions, like starting with programming and so on. But it turns out that the schematic CLI, by default, is running in debug mode. And debug mode means that it won't actually execute actions on the file system. So if you ever get to that point, you need to disable debug. And let's see what happened now. Yay, we got our change. Just to be sure, I'm going to see here. So we have our package.json, and we have the new dependency. Pretty cool. What will happen if I run the schematic again? Any guesses? Well, it will add the dependency. No, it won't add the dependency because there is already such key, right? Awesome. The other example I wanted to show you is how we can create files from templates. And this time I'm going to show you an example from NativeScript Schematics. And here we have a folder called files, _files. And this is basically the source for our templates. What we have inside, we have an Angular JSON. But it's kind of different than the usual Angular JSON. It looks similar, but there are these weird things here. And these are just options that we can pass through the row to the template. For example, if you pass the name option, this string here will be replaced with the value of the name. And we can also use options in the name of the files, of the templates. So if I rename the Angular JSON to --name.json, this is the syntax to do it. It will take the name property and it will rename it. I'm actually not sure if that was the right syntax, but you get the idea. Let me revert that quickly. All right, how do we use that template inside the rule? Shortly, OK, this is quite long, so let me start from the innermost level. We have URL. URL, we need to specify the base for the template, right? Then we have an array, and in that array, we can provide different rules. And we're interested in the template function, which is provided by Schematics. It's imported from Angular Dev Kit Schematics right here. So we can provide, we can use template, and we can provide different options. This is where the values of the options will be replaced inside the template. Then we use the apply function, which returns the source. And the source is basically, the source need to return some tree. But these are just specifics. You shouldn't care about them. And then some more specifics. The source returned from the apply function should be merged with our existing tree. And branch and merge also returns the tree. So just remember that template. What I do is I copy it every time I use it because it's hard to think about it, honestly. All right, let's try to use the Angular JSON schematic. Again, the schematic COI :Angular JSON. And what happens, I should have been more surprised, but I know this will happen. We get an error. And if we see that error, it means that the name option is required. It's not very obvious, but yeah, let's say that the name option is required. So when executing, we need to provide name. For example, India is awesome. I love the food here, by the way, just saying. OK, so now if we see the Angular JSON file, now it wasn't generated because I, again, need to provide debug false. And if we see the Angular JSON file, we see that some of the things are replaced. And the source root, if you noticed, it was an option there. But it's actually, by default, it's dot. So if you provide, first, what will happen, let me remove the Angular JSON file. If you provide source root equals India and cat the Angular JSON again, we will get that replaced here. This is how we can pass options. And again, it's the same from the Angular CLI. Nice. And again, because I generated the file, so I have a real physical file, if I try to execute that again, I will get an error that the Angular JSON file already exists. And this is the default behavior of schematics, but you have different, actually, options. You can also overwrite files or don't throw errors when you see conflicts. All right, I think that's all I wanted to show you. And you can find me on Twitter at Stanimira Vlaeva, or just you can call me Mira. I'll be here around. And thank you for your attention. Thanks.
That was wonderful. Thank you very much, Stanimira.